Hello, welcome to the lecture 21 in the UML class models. And so let's do some recap first. In the lecture 20, we introduced the UML through a case study. We have the clinic system where we have the staff management and patient management, appointment prescription. And the use case diagram gave a user-oriented perspective, and the authors it's the user who playing the role, and the use cases takes the task that the user does with the system, and we need to identify the candidates that the candidate use case by finding the active use cases by finding the active verb phrases, identify the candidate classes by finding the noun phrases. And the class diagram shows the association between the classes. And we are going to do the iterations one and the hierarchical generalization of the system. So today we are going to finish the case study, the sequential diagram, and state diagram. I'm going to introduce the UML class model, the sequential diagram. So the system in action. The class state diagram gives a static view of the system, and we all know that nothing is we know nothing about dynamic behavior. In the UML, we can use the iteration diagram to show how the message is passed between the object of the system to carry out some task. This will show how various classes realize different use cases we identified in the use case diagram. In an example sequential diagram, so booking appointment, when you consider what happens in the appointment booking scenario, a patient wishes to make an appointment, the reception must check the person is a valid person and the doctor object. And the doctor object must be checked to see if there are any available appointments. If there are suitable slots available, new appointment should be created and assigned to a new doctor. Therefore, it's just like the one we mentioned last time about the sequential diagram, the state diagram. It's just all we have talked about. And we're going to talk about a good class models, where a class model shows the class of a system and the association between them. Okay? The class model is we show how many classes we have within a system and the association between them. A class model should help us to meet the objective to build a system which satisfies all the current requirements and build a system which will be easily maintained and evolve. A good class model consists of classes which don't depend on particular functionality required today. And good classes have good names, definitely. A good class model has a class that don't depend on particular functionality required today. Does not a good class model consider class that don't depend on particular functionality that is required today. Then we are going to deriving the classes. We have seen the non-identification techniques for that, and there are two main extreme techniques to find the classes in general, which is data-driven design (DDD) and responsibility-driven design (RDD). So the data-driven design identifies all the data of the system and divide it into classes, assign the particular responsibility of the method to these classes, and the responsibility is that identify all the functionality at work called responsibility of the system, divide them into classes, and find each corresponding class requires. So therefore, how do we find a good class name? We need to find maybe a PU.所以这是 in Chinese 是复数的多元的，对，就你做一个 class 不能说这个就是它没有，因为 class 本身就是一类，好吧？你类在本身里面就有好多，它就是一个集合概念，一个集合里面肯定有很多元素，对吧？ Therefore, we are no need to do the pronouns. We're going no person. We only says the person as a class. And the no verb, which means that no encrypt, and maybe we have the encryptor or encryption helper. and no general process description, which means the encryption is like print manager, no printing. It's like print manager, print helper. A simple class model in the UML model, class is shown like a rectangle containing the class name and just like a doctor class, and association, which means that the class is sort of corresponds to nouns and association corresponds to verbs. Association express the relationship between the classes, and the instance of the classes, the instance of the associations, which is the links with UML. And the links in the UML, I'm not really sure about that. And additionally, we are going to say that the association is the relationship between classes, and the kind of the nouns, and the association kind of the verbs. And there are some examples of the associations. We are object of classes, and the object send a message to object of class B. Object of class A creates an object of class B. The object it has the attribute of type class B, and the object A receives the message with the object of class B as an argument. Yes, it can be done, and the object of class A is now has to know about the object class B. And the multiplicity helps us to quantify the association. For example, for classes where a doctor has multiple patients, where has exact number, which is 1, and the range of the numbers maybe the dot 1 dot 10, and the an arbitrary unexpected number to infinity, which is maybe asteroid. And the example is that a doctor is associated has associated with many multiple patients. A is one doctor, and the end of the association we have maybe 1 to 1, and the 1 to many means the patient at the other end of the system. And the operation attributes and operation here, the attributes describe the data containing an object of the class of the type. And it is worth noticing that what if the plus is the power rate, what if the minus is the pi rate, and what if the hash sign is protected. And the operator defines the ways the objects may interact, which is just like the signature of the class. Yeah, exactly. And which is called the signature of the operation gives the selector, the names, and the type of the form of argument and the return type. So the selector and the name, that's where argument type. Okay, I see. So it's the argument name. Selector is just the function name, and argument type and return type. Cool. And generalization is just like the inheritance in Java, and every attribute of the superclass must be inheritance by the subclass. And then we are going to introduce the CRC card, which is called Class Responsibility Collaboration. And the CRC card helps to check the good design and the guide for retirement. The CRC card is not a part of the UML, and it has very useful insight through the development. So how do we encrypt a CRC card? It is the name of the class at the top, and the responsibility on the left-hand side, and the collaborator of class on the right-hand side. So just like that, name, responsibility, and collaborators. And then we're going to go to the CRC card examples. For example, we have the library manager. We have the responsibility of maintain the data about the copy of current has the collaborator copy. Responsibility maintain the data of the particular copy of the book, inform corresponding a book when it's borrowed or returned, and the collaborated book. The book class will have the responsibility to maintain the data about one book and know whether it is borrowable, copied or not. So everything, this is a good design, and we go to a bad design, which means we have a word processor class, which has so many attributes, responsibilities, and so many collaborators. That's not good. And thing class is that the screenshot diagram adds the details to the use case by showing the workflow and the object. By showing the workflow and the objects involved, the state diagram shows how an object the state diagram shows how an object state can be exchanged by messages received. And the class diagram, state diagram is just the state how to change. Class diagram is the static nature, and the sequential diagram is the one use case, one workflow. And we discussed how classes or association can be found, about the concept of the multiplicity. And we discussed class attributes and operation. We looked at the responsibility of generalization and the CSS card. Okay, that's all. Thank you very much. Welcome comments and subscriptions.